Alright, welcome to my YouTube channel. This is Grace Tutor, and what I do on this YouTube channel is that I solve technical drawing problems, and I also provide important information that you need to have a better performance in your technical drawing examinations. And if you are new to this YouTube channel, you are watching my video for the first time, I really appreciate you watching this video, and I want to tell you that if you're a technical drawing student, subscribe to this YouTube channel and make sure you put on notification bell so that whenever I upload a new video, you'll be notified. And also help me to share my videos with your friends who are also technical drawing students. And the most important part of this subject is for you to practice it. If you are to master it, if you are to tackle any problem, and you need to practice this subject. Very, very important. Now, what I want to do here now is that someone made a request that I should help to solve question 5 on this question. This is engineering drawing 1 by Pick Up and Packer. So I once solved one of the questions here. Now someone requested, as I said, that I should help to solve question 5, as you can see on the screen. So I'm going to read the question, then I need to make some explanations on how a problem like this can be solved. So let me read question 5 for us, as you can see on the screen. And it says that an ellipse, parabola, and hyperbola have a common focus 40 millimeters from the directrix. Draw all three curves if the eccentricity of the ellipse is 2/5 and of the parabola, of the hyperbola 3/2. So the eccentricity of ellipse is 2/3 and that of hyperbola is 3/2. So where is that of the parabola? I'm going to explain that right now. Let's go. All right. Now, I've done some work on this paper, and I believe you can see it on the screen. Let me bring it up. Okay, you can see it. So I want to talk about some things pertaining to this particular question that I just read. Number 1 is that the eccentricity is the ratio of the vertex distance from the focus and vertex distance from directrix. That means eccentricity is equal to vertex distance from the focus over vertex distance from directrix. So what is focus? What is directrix? I'm going to show you that when I begin to draw, but I need to explain some things here. Now, the next thing I want to explain is that for ellipse, its eccentricity is less than 1. As you can see in the question, that the eccentricity of ellipse given to us is 2/3, which is less than 1. So here from the question, as I said, eccentricity is 2/3 for ellipse, and I'm representing that with V1F over V1C. Okay, I will tell you what F means and what C stands for as I'm moving on in this explanation. Now for parabola, the eccentricity is equal to 1. The eccentricity of a parabola is 1. So from the question, we can say that the eccentricity of the parabola is 20/20, which is equal to 1. And I'm representing that with V2F over V2C. Okay. Then for hyperbola, the eccentricity is greater than 1. And from the question, we know that the eccentricity is given at 3/2. And I'm representing that with V3F over V over V3C. Now, as I said here, that where V1 is vertex of the ellipse, V2 is vertex of the parabola, and V3 represents the vertex of the hyperbola. F is the focus, and C is the point on the directrix. Now, from the question, CF, that is distance of the point on directrix and the focus, is 40 millimeters. So based on what we are given as the eccentricity of the ellipse as 2/3 and that of parabola as that of hyperbola as 3/2, I have to find the sum of the ratio because they are in form of ratio. So I can just add this together, or what I did here is that I have 2 plus 3, which gives me 5. It means that V1F, that is the distance of the vertex of the ellipse from the focus is equal to 2/5 times 40, which is equal to 16. And then VF, that is V2F, that is the distance of the vertex of the parabola from the focus is 20 millimeters. And V3F, which is the distance of the vertex of the hyperbola from the focus, is 3/5 times 40, which is equal to 24. I believe this little explanation that I've made is clear to you, but as I'm doing it practically, you will understand what I've explained here. You don't have to worry yourself. Let's go. Now, the first thing that I need to do here is to draw a vertical line. So draw a vertical line. Okay. So draw a vertical line. So draw a vertical line like this. Okay. Now, so let's move our T-square to somewhere here like this and draw a horizontal line like this. So the vertical line that I drew here is the directrix, and this horizontal line is the axis. So this point where the horizontal line and vertical line intersect is point C. So on directrix, so we have this point C here. Okay. Now I need to locate the vertex of each of the curve. So I'm starting first, taking a measurement of 40 millimeters, as we are told that the three curves, they have a common focus, which is 40 millimeters from directrix. So this is point 40 here. This is point 40, and here this is point F, so which is the focus for the three curves. All right, so next, for me to locate the vertex of the ellipse, which is 16 millimeters away from the focus. So this is the point, 16 millimeters away from the focus. So this is the point. So here I have, so this point I will call it V1 as I explained. Then for a parabola, the distance of its vertex from the focus is 20 millimeters. So this is 20 millimeters here. So here I have V2. So let me put it up here, V2. And for the hyperbola, the distance of its vertex from the focus is 24 millimeters. So I will take a measurement of 24 millimeters. So this is the point, 24 millimeters from the focus. So this is V3. So this point here is V3. Okay. So I've located the vertex of each of the curve. Now, having done that, so next thing that I'm going to do here, I want to draw the curve, but I need to do some things. What I need to do is that I need to erect perpendicular lines. Perpendicular lines on this line. So this is what I'm going to do. Distance from here to here is 8 millimeters. From here to here is 16 millimeters. That is distance of V1 from the focus is 16 millimeters. So I will divide this 16 millimeters into 2. That is 8 millimeters. So I will take a measurement of 8 millimeters here. This is 8 millimeters. So I will now take 8 millimeters, like I'll just take like maybe this is 1, this is 2. So I will add 10 to it. So that is so this will be 24, and this will be 32. So this is 40. So this is 48. Okay, 48, and this is 56. 56. This is 64. So 64. So the next one will give me 72. So let me count it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I still need to add. So 9. So this is 10. And this will be, so that's 10. So this is 11. And this is 12. So I will stop it there. So 12 is enough. So if it is not enough, I will still add to it, but I think this 12 is enough, though I've confirmed the work. So 12 is enough for now. So I'm going to draw a vertical line on each of these points. So I will pause the video and I will come back after I'm done with that. All right, so I've drawn the vertical lines on each of the points and I've numbered 1 to 12 from here to here, 1 to 12. So this is the vertex for the ellipse. So I want to draw the ellipse first, and the method we are using here is known as locus method. So I want to draw the ellipse first. So what you need to do is that you draw a short vertical line at this point V1. So draw a short vertical line. This is okay, like this. Then you take your compass, so put it at point V1 here and extend to F. That is the focus. So extend it to F, that is the focus here, and draw an arc like this. So draw an arc like this. So wherever it touch the vertical line, so let's call it point E. So let's call it point E. Now, the next thing that you have to do is that we have to draw a line from point C here, passing through point E. This is what I mean. So from point C, that is a point on directrix, draw a line in this direction. Okay, so draw a line in this direction. So where this line touch these vertical lines, I'm going to, so this will be point 1. This is 1. This point is point 1. This is point 2. This is point 2. This is point 3. This is point 4. This is point 5. This point is point 5. This is point 6. This is point 7. This is point 8. This is point 9. This is point 10. So I still need to extend this. Okay. So this is point 11 and this is point 12. Okay. Now, so the next thing that we are going to do is that I will take my compass. I will take my compass. You need to pay attention to what I want to explain here now. So put it at 1 here, at 1, and extend it to 1 along this line. So extend it to 1 here, like this. Okay, take this distance and put it at the focus here. And you make an arc here. So you make an arc here. And make an arc down here. Okay. All right, next, so you take this distance, that is 2. So take this distance. So it's already on the focus, just make an arc down here. And we have the second arc at this point 2 here. Okay, so the next is 3. So take this distance. So this 3 here, put it at the focus and make an arc here. So make an arc down here. Then 4. So extend to this point 4 on this inclined line. Then you take it, bring it to the focus. So make an arc here and make an arc down here. So next is 5. So you extend to this point on the inclined line. So bring it to the focus. So you make an arc up here and make an arc down here. So next, so put on 6 here and extend to point 6 along this inclined line. Bring it to the focus here. So you make an arc here and make an arc here. So next at 7, so extend to this point 7 on the inclined line. Then take it to the focus. So make an arc here and make an arc here. Then 8. So extend it to point 8 on the inclined line. So extend it here and bring it to the focus. So make an arc here and make an arc here. So I'm going to do the rest while I pause the video, then I will come back when I'm done. Alright, so all the points have been located. So I did it up to 11. I don't have to do it for 12. So I don't have to do it for 12. So this point 12 will be the second vertex of the ellipse. So this is the second vertex of the ellipse. I've confirmed this work. I've worked it out. So that's why I said we should stop it at 12. 12 is okay. So we are going to join this point. So all these points. So let me bring them out for you to see them. Okay. So all these points, we are going to join them together with the use of a French curve. Okay. So this point, including this point, that is V1. So then this point here, this point, this point, this point, this point here, this point, this point, this point, this point, this point, this point, and back to the vertex here. Okay, so all these points, we join them together with the use of a French curve. So I'm joining them together here. So just look at the way I'm going to do it. Okay, so we join this together like this. Okay, so and then so join this together. All right, so then I will join this together with the vertex on the right side, that is V1. Then I'll turn it here like this. So I'll join this together. So I have to okay. Then I will join these together. Alright, so that is the ellipse. So we have produced the ellipse. So the next thing I'm going to do is to produce the parabola. So the vertex of the parabola is V2 as we have here. So V2 is between V1 and V3. So what you are going to do now is that, so you come to this point V2 here and you draw a vertical line. So draw a vertical line like this. Okay, so this is okay. So draw this vertical line on V2. Okay, so take your compass and put it at V2. Extend to F here. That is the focus. Don't forget that the three curves, they have a common focus as said in the question. So draw an arc like this. Okay, so wherever this arc touch here, so we call it, let's call it E1, point E1. Okay, then the next thing is, so draw a line from the point C on directrix through this point. So this is it. So draw like this. Okay, so I will just produce some. So if I number this, so this is point 1 here. So this is point 2, this is point 3, so this is point 4, this is point 5, 6, 7. So I'm going to locate the points now. So that is, we put our compass at 1 here. So we extend to 1 on this inclined line E1. So we take this distance and we put it at the focus here. So we make an arc here. and make an arc down here. Then we put it at 2. So take the distance. So the point is already on the focus. So now, we take the distance from here to here. So for 3, so put it at this point. So we take the distance from here to here. So bring it to the focus. So make an arc here and make an arc here. So I will do the rest while I pause the video. Alright, all the points have been located. So we have all the points like this. Then it goes like this to 7 here. So I'm going to join these points together. So I'll join this point together like this. Okay. So I'll join this together. So don't forget that what we are producing now is the parabola. So we are producing parabola. So join this point together like this. Okay. All right, so then the upper one. So the upper ones. So I join this together. So we join all the points together with V2. That is for the parabola. So this is the parabola now. So I produce the parabola. So the next one is the hyperbola. So what you need to do is that, so as we did for the ellipse and the parabola, so at this point V3 here, that is the vertex of the hyperbola. So draw a vertical line up like this. Then take your compass. So put it here at V3 and extend it to the focus. Then draw an arc like this. So wherever this arc touch on the vertical line, so this is point E2. So this is E2. So then take your ruler. So from point C here, so draw a line. So draw a line from point C passing through E. So this is okay. All right, so then by number this, so this is going to be, so point 1, okay? So this is 1 here. So this is 2, this is 3, this is 4, and this is 5. So I will only produce these 5 points. It's okay. It's enough. That 5 is enough. So I will take my compass. So put it at 1. Okay. Don't let me call that 1. So I want to erect one line here. So let me erect a line here. Okay. Okay, so this is going to be my 1 now. So this point will be my point 1. So this will be point 2. This is point 3. And this will be point 4. So this will be point 5. And this will be point 6. But I'm not going to produce up to 6. So then, so put the midpoint of compass at 1. So at 1 here. So extend to 1 here. So put it at F and make an arc here. Then you make an arc down here. Then we put it at 2 here. So put it at F. So make an arc here. So make an arc here. So I will do the rest while I pause the camera. So alright, all the points have been located, and these are the points like this, passing through point V3, which is the vertex of the hyperbola. So I'm going to join this point together to with the vertex. So I'll join this. Okay. Okay. Then I'll join these ones. All right, so we have, so this is hyperbola. So this is hyperbola. This is hyperbola. So this is parabola. And this is ellipse. So this is ellipse. All right, so that is all that we are required to do here. So, and then the same person also made a request that I should solve question 8. So question 8, I'll just explain that what I did here is all that you need to do to solve question 8. Question 8 says that a hyperbola has its vertex 12 millimeters from the directrix and its focus 20 millimeters from the vertex. Draw the curve using the locus method. So you have to use this method as I did here. So let me explain that. We are told that the distance of the vertex from directrix is 12 millimeters. That means distance from here to here. Distance of V3 from C here should be 12 millimeters. And the distance of the vertex from the focus is 20 millimeters. Or the distance of the focus from the vertex is 20 millimeters. That means distance V3F is 20 millimeters. So all you need to do is to take a distance of 12 millimeters from this point on directrix to this point, then take 20 millimeters from here to this point to locate your focus, and then use this method to get the curve. It's as simple as that. So I believe you can do that. So thank you for watching and thank you for listening. Keep on practicing and I really appreciate you. Thank you. God bless you.